good evening, everyone. So in the last session, we have already completed your multi-threading module. And today we are going to start with the last module, that is collection framework. So there are different types of collections in collection framework, and why we need the collection, that also we are going to see in the today's session. So what is the need of collection? We have different data structure to store the data. Basically, we store the data using arrays so that it will be stored as a temporary. Okay, then we can store the data using files. So that is permanent storage. So when we are creating files, that means you are using secondary storage, and that is nothing but permanent storage unless and until that file is with you. That will, other than that, how can we store the data? So if you want to store the data, which is in the huge number, and you are not able to use arrays for that, that time you can go for the collection. So even though we have arrays to store multiple values in one object, but arrays have disadvantages such as fixed size. Whenever you are creating any array, you need to give a size to that array. We cannot extend it. That means we cannot grow it or shrink it once it is created. Same, the second disadvantage is fixed type. Fixed type means you can store only the fixed type of data. If you are creating the integer type of array, then you can store only integer data. You cannot store any other type of data. Right? To overcome all these advantages of arrays, collection was introduced. Collection was introduced. Then what is that collection is? The collection is a framework containing many classes and interfaces, with the help of which we can store group of objects at one place. So we can store multiple data using the collection framework, or you can say the classes and interfaces provided in the collection framework. Collection is also the name of the interface, that is a parent interface of list, queue, and set interface. Okay. All implemented classes of collection are also called as collection. So basically, what are the collection? It is a framework. It is providing you some data structure to store the data, which to overcome the disadvantages of arrays, we can use the collection frameworks, interfaces, and classes to store the data. Okay. So what are the basic types of collections? There are two types of collection. First one is the generic and second one is the non-generic. When you use the generic collection, that means you can store any type of data into it. That means you are creating any particular collection, and you can store integer type of data, double type of data, string, object, anything into that particular collection. Okay, so that is known as a generic collection. Here the collection is a type set, meaning only one type of values can be added. Okay, the non-generic collection, whatever I have explained, that is a non-generic collection, because we can store multiple types of data into a set in a same collection. Okay, this is not a type safe collection. That means type is not completely given. Okay, it is not type safe means we are not fixing its type. We can store any type of data into it, and because of it, there may be chances of getting exceptions. So non-generic collection is nothing but which is a not type set. We can store any type of data into it, and this type of collection is not encouraged also. We mostly prefer the generic collection where we can store one type of data into it, like arrays itself. There we are creating the integer type of array, and we can store only integer data. Similarly, in the generic collection, you can create any type of array, and you can store the data into that array only of that type, whatever you are mentioning. So how will we make the collection generic? So we are going to use the diamond operator, which we have already seen. Okay, so we are using diamond operator for making the collection generic. Now, what are the benefits of collection framework? So it reduces programming effort. It is easily available, and you can use all the methods easily. It increases the program speed and quality also. It allows interoperability among unrelated APIs. It reduces effort to learn and use new APIs, reduces effort to design new APIs. It is already developed. So you just need to use these different data structure to store your data. It fosters software reuse. Okay. So basically, this collection framework is going to be used for storing the data into different data structure according to your need. Now, what are the different data structures, or what is the hierarchy of collection framework? So in the hierarchy, as we have seen that there are three different interfaces, that is a list interface, queue interface, and set interface. It is the child interfaces of collection interface, and the collection interface is the child interface of iterable interface. Okay, these are all implementation classes of that particular interface. So list interface is nothing but a list data structure. If I say to you that I want to write down a shopping list, so what we will write? We will write some 1, 2, 3, 4 number, and we will write some atom which we want to shop, right? Similarly, this is also a list data structure. It's similar to the listing, how we use the listing in real life. Okay, same list is here we are using. There are 4 different implementation classes for this particular list interface or list data structure. First one is the array list. Array list is similar to the arrays. Only the difference between array and array list is we don't have to give the size of the array here. It will be automatically increases, or this array automatically grows and shrinks according to our need, or according to our programming or application need. Okay. Second one is the linked list. Linked list is again the linked data structure, where the data structure is nothing but we use nodes which uses pointers and addresses to the next node. Third one is the vector. Vector is also known as you can say it is similar to the list itself, or array list. You can say it is similar to the array list, and in vector the difference is that array list is non-synchronized and vector is synchronized. Okay, that this vector is also known as legacy class because it is introduced in JDK 1.01 version itself for storing the data dynamically. It has one child class, that is a stack. Stack is again one data structure where we can store the data. I have already explained the method stack, right? So how the stack works, whatever the data you are going to enter first, that will go at the bottom of the stack. Then the next data will come at the top of the stack. Okay, so this will work as a stack itself. Second is queue. In real life, we use queue, line, right? We use, suppose you want to book some tickets. So we stand in a line, right? In the same way, this is a real life line itself, the queue interface. It maintains the first in, first out order. Okay, that means whatever the data goes first, it should be removed first or get out first. Okay, it has one implementation class, that is a priority queue. What are these? That we will see later while programming itself. Second is the DQ interface, which is the extended interface from the queue interface. DQ is also known as double-ended queue. So queue has a one head itself, and whatever operations you are going to perform, that will performed on a single opening. But DQ has 2 openings, rear and front ends, and we can perform the operations like insert, update, delete. All these operations we can perform from both the ends. So that is the only difference between Q and DQ. So DQ interface has the implementation classes array DQ, direct implementation. Linked list class also implements this DQ interface, the methods of the DQ interface. Third one is the set data structure. Set data structure. You must have learned the set in mathematics. We calculate the union, the set operations are there, right? Intersect of the set, common elements from the set we can retrieve. Similar to that data structure, the set data structure is introduced in this collection framework to store the unique elements into the sets. So set has two implementation classes, HashSet and linked HashSet. HashSet is basically set interface uses internally map interfaces implementation. Map is not a part of collection. It is not a direct child of collection interface, but we consider this map collection also as map interface also as a collection framework part. Okay, it is not a direct part, but we consider it as a part of the collection framework also. So HashSet and linked HashSet. HashSet is nothing but uses hashing algorithms to calculate the hash code and then store the data into set. Linked HashSet, it is similar to the linked list. These are using the pointers to store the addresses of the next node. Next one is set interface. Child interface is sorted set. It has one implementation class, that is a TreeSet. The TreeSet uses binary tree structure. You must have learned these concepts. So binary tree structure, that means there is a node. It looks like a binary tree. That means it looks like a tree. It has branches. The left-hand side of the branch always have the smaller value than the root node, and right side of the branch always have the higher value than the root node. So it creates the binary tree. Each root will have only two branches. Okay, that is the tree set. It also used to store only unique elements. So basically set data structure stores unique elements. That is, it will never stores duplicate elements. In the list, we can store duplicate elements. In the queue, we can store duplicate elements. Okay. Then map. Map is not direct part of the collection framework, but we consider it as a part of the collection framework only. So map, it has a key and value pair, always uses or always stores the data into key and value pair. It has two extended maps. It also has HashMap as the implementation class. It uses the same hashing algorithms and stores the data into key value pair. It has two child interfaces, sorted map, and sorted map has navigable map interface, and it has a tree map interface. So basically, set data structure internally completely uses map data structure to store the data, because map also doesn't store duplicate key data. Okay, values can be duplicate, but keys cannot be duplicate. So set data structure internally completely uses map data structure. So HashSet uses HashMap implementation class. Linked HashSet uses linked HashMap implementation class. TreeSet uses TreeMap implementation class. Okay, so this is the collection framework hierarchy and different data structures. Till here, anyone has any doubt? Understood till here? Okay. Now we will say one by one. First one is the iterable interface. It is a parent interface or root interface for the entire collection framework. The collection framework is already defined. All these interfaces and these classes are defined in the java.util package. Okay, these are utility classes. These are providing you some utility part. That's why all these are provided in the or defined in the util package. So the collection interface extends this iterable interface. Therefore, inherently, all the interfaces and classes implement this interface. So all collection framework have the parent or root interfaces, iterable interface. The main functionality of this iterable interface is to provide iterator for the collection. That means how we use the for loop for displaying the data or to iterating over any array. Similarly, if you want to iterate over this collection, all these collection which we have seen, we use iterator. Okay. Therefore, the interface contains only one abstract method, that is the iterator method. Iterator object. Okay, so this iterator method is there in every collection apart from the map. Okay, map doesn't have this because it is not a direct part of the collection or direct child of the collection or implementation. Okay, that's why map doesn't have this iterator, but all the other hierarchical classes which is implementation classes and interfaces. All these have the iterator method by default. Next one is the collection interface. So interface that extends iterable interface. This is a child interface, and it is implemented by all the classes in the collection framework. This interface contains the basic methods. What the collection interface contains? It contains basic methods, which every collection has, like adding the data into collection, removing the data from the collection, clearing the data, or any other operations which is common for all the collection framework. All these methods are implemented in the interface because these methods are implemented by all the classes irrespective of their style of implementation. Style of implementation means irrespective of their data structure. All these methods are implemented by the implementation classes. And having these methods in the interface ensures that the names of the methods are universal for all the collections. So that if you are using any data structure from these data structure, like if you are using list, if you are using queue and set, any data structure or DQ interface, we will have the same name for the methods for performing the basic operations like adding, removing, clearing, etc. So that's why all these methods are defined or declared. All these are abstract methods as it is an interface. So these are already declared here in the collection interface. Therefore, in short, we can say that this interface builds the foundation on which the collection classes are implemented. So it is providing you some structures, data structures to store the data in different ways according to your need. Now you will say that how will we think or how will we select any data structure from these different data structures? How can we identify? So as per your need of the application, suppose you want to save the data, duplicates also you want to store, then you can go for the simplest data structure, that is a list. Second one is if you want to store the data or if you want to serve the request according to the sequence it is come to you and you want to serve accordingly, that means the first come first serve basis, then you can use the queue data structure. Like we use book my show for booking any events, right? So the how we can book, so whatever who will come first for booking that particular events ticket will be served first, right? Same thing if you want to perform some such kind of bookings or any other request serving, then you should use for queue interface. Then when you don't want to store the duplicate elements, you just want to store the unique elements and you want to perform operations on the unique elements, then you should go for the set data structure. Okay, so according to your need of application, you should select any of these three data structures and any of these its implementation class. Apart from the, if you want to store the data into key values pair, then you must go for the map data structure, which stores the data into key and value pair. So what are the different methods are defined in the collection interface? First one is the add method. So this add method is used for adding any element into the collection. This add method is there in every collection implementation class. Second one is add all. If you want to store any other collection elements into one collection, then we use add all. It will be used for adding all the elements of the given collection to current collection. Clear is used for clearing the collection. That means it will remove all the elements from the collection. Contains always used to check whether the given object or given value is present in the specified current collection or not. Okay. Contains all, it will again this returns boolean value true or false. Okay, contains all also returns boolean value true or false. So contains all is used for checking whether this collection elements are present in the current collection or not. Equals is used for checking whether the objects current collection object and this object is equal or not. Hashcode method is used for calculating and returning hash code for this particular collection. Is empty always used to check whether there are any elements into the collection or not. Iterator, as I said, iterator is used for iterating over the collection. It returns iterator object. Is empty returns Boolean value. Max, to return the maximum value present in the collection. Parallel stream, it will be used for returns the parallel stream with this collection as its source. Then remove is used for removing the element, given element, basically given object from the collection. If that element is, if there are duplicate elements, then the method removes first occurrence of the object. Okay, it will never remove all. If you want to remove all the values, then you should use other methods. Okay, remove all is used for removing all the particular collection elements from the current collection. Remove if, so here we can provide the predicate in reference. Retain all, that means retain only elements from this collection and contained in the specified collection. Size is used for retrieving the size of any collection. Split iterator split iterator is again another interface in this collection interface. It is used for it to create the split iterators over the elements in the collection. Stream method returns the sequential stream with this collection as its source. ToArray method is used to return the array. That means it will give you the array representation of the current collection. Okay. So these are all collection interface methods. I will show you these methods here. First, we are going to see the list example. Okay, so first I am opening this collection interface. You can see it is extending the iterable interface, and these methods are there: is empty, contains, iterator, to array. Okay, there is one default method also, add method, which is used for adding any element. Remove method is used for removing any elements. For bulk operations, these methods are there: contains all, add all, remove all methods are there. Okay, these are different methods of collection interface. Now we are going to see the list interface, the list data structure, how it works. It is the child interface of collection interface. This interface is dedicated to the data of the list type, in which we can store all the ordered collections of the objects. Okay, we can store ordered collection, means some order should be there. This also allows duplicate data to be present in it. This interface is implemented by various classes. Examples like ArrayList, LinkedList, Vector, Stack, etc. Okay. So since all the subclasses implement the list, we can instantiate a list object with any of these classes, like in this way: list with new ArrayList, list with LinkedList, list with new vector. Okay, where T should be the type of object. Okay, this is a diamond operator. We always use this diamond operator for storing the what type of data you want to store, what type of list you want to create, that you should mention here in the diamond operator. Okay, so T is always the type of object this particular list is going to hold. Now, as this is the upcasting concept, as we have seen. If you want to create, you can create the object of these classes directly also, instead of using the list interface reference. Okay, now we are going to see one example for the list interface with all the different classes. So first we are going to see the ArrayList class. ArrayList. Okay, so the implementation classes first is the ArrayList, which is implementing abstract list. Abstract list is again the interface. Sorry, this is a class which implements the list interface. Okay, it is abstract collection. The hierarchy is huge. Okay, these are all abstract classes. That's why the name is abstract. And this particular abstract collection is implementing collection interface. That means this abstract collection has all the methods implemented, all the methods which just we have seen. Okay, So abstract list is used for creating list itself, which is a type of abstract. Now we are going to see the ArrayList class. So the implementation classes of list, first one is the ArrayList. ArrayList provides us with dynamic arrays. These are dynamic arrays in Java. It grows or shrinks automatically. ArrayList is non-synchronized. If there is a situation that you don't want to save the data into synchronized form, then you can use this ArrayList to store the data. How to store the data into ArrayList? So the first sequence is like normal way, like how we have used our arrays to store the data. Similar way, I'm creating one object of this class. It is in the util package. So this should be imported. Now here, this is a non-generic type, as we have not mentioned in here any diamond operator type object. So it is a non-generic type. You can store any type of array data into it, like using add method. So we can store 2, which is the integer value, a dot add. This is double value, a dot add. Suppose I'm using string value also. Okay, this is a non-generic collection, and this is not recommended, not encouraged. Non-generic collection. Okay, this array list is non-generic. We can create the generic list using this is the one way directly creation of the object of the implementation class, or you can use the list reference to create the array list. Suppose here I want to store only character data. Okay, so if you are using the primitive types as a type, it will never take as an input. Okay, whenever you want to give some primitive type of data, you always use wrapper classes in the diamond operator. So for the char, we need to use character wrapper class, so that this list will hold all the characters data. Now, L.add is the method where we can store the character data. Character should be in the single quotes. Okay. Then there is one more method in the add, as this is a list, ordered list. Okay. So here you can store the data directly based on the indexes. List interface is nothing but the list collection. Okay. So list data structure. All these are ordered collection. That's why these implementation classes are based on indexes. So we can store the data based on index. We can retrieve the data. We can remove the data based on indexes. Also, now these methods are overloaded methods, and these are defined in the list interface. Suppose I am using add method. 6 value I am adding. 6 character I am adding here. L.add. X character I am adding. Okay. So basically I have added 4 values into this, one with the index. Okay. Now, suppose you want to see what the data elements we have into this list, we can simply use system.out.println list elements. Only the reference. We can see the elements stored into the list. So as we have mentioned the one index here, so this L value is stored at the first index. Okay, this is add operation. Now, suppose you want to display the elements, we will create similar way. We can retrieve the element from this particular list. contains value at index 5. Okay, I will use 4 because we don't have 5. So we have a get method, L dot get method, where we can pass the index 4 just to retrieve the value present at the given index. Okay. Okay, so we don't have the 4th index, we only have the 3 index values. So it is giving us exception. I will change it to first. Okay, so we will get the value which is at the first index. Okay, that is L. Similar to that, if you want to remove the element, now I will add one more element. Duplicate element. Suppose 6 value I'm adding duplicate. And one more value I'm adding duplicate. At second index, I'm giving index now. And the value should be B. Okay, so 2 duplicate values. And if I try to remove the element, you can remove based on 2 options. First one is using index value directly or using the value which you want to delete. Okay, so this method remove returns the value which is deleted, removed from the element. This returns Boolean value true or false, whether that is present. If it is present, then it will only remove the first occurrence. Remove index. If you are performing the operation based on indexes, then only the value present at that index will remove, and whatever the value gets removed, that you can see here, because it returns that type of element which is removed from the list. Okay. So I am going to use remove method, and I want to remove B. Before that, before removing, I will display the elements in another way. List elements. Instead of this, you can use here another syntax also for displaying elements. You can use normal for loop, iterate over collection. Okay, now here you can use iterator, and it takes one by one character from your collection. It has a iterator method. Iterator method always return the iterator reference. Then the iterator has next method and next method. Okay, it has only these 3 methods: iterator, has next, and next. Has next is used to check whether the current collection has more elements or not. If it has more elements, then it will return true. If it doesn't have any element, then it will return false. Okay, so to get the next element, we need to use next method. So it will take the next element, it will read the next element and store it in. This is not necessary to do, but as this next method returns object, we need to cast it into character because we are creating list of character. That's why we need to convert it into or cast it into character and store it into one character variable. I'm using system.out.println statement to display the list elements. I will use print method, and then we will use println removing B from list. Okay, after remove, we can again see the list. System.out.println list after remove. Now here one more syntax we can see that here, instead of this iterator writing inside the for loop, you can write it outside it, like here L dot iterator. It returns iterator reference. You can store it into iterator. changed here itself. I will create another one. Okay. Now this iterator needs to be specified with the type, what type of data you want to iterate over it. So this should be character. And then you can use while loop using these two methods itself, has next and next. So first we need to check whether the this collection has more elements or not. So we are going to use it.has next method. If it has more elements, then we will display the element directly it.next. Here you don't need to cast it. It will directly display all the elements. And at the end, I am displaying new line character. Okay. So here we have seen three different ways to it. For iterating, we use for loop or while loop or any other loop using these methods itself, using iterator method. But the syntax is, if you want to display any elements, then you can use only reference also, as these are using toString methods. That's why all the elements will be displayed automatically. Or if you want to perform any operations, then you almost complete or compulsory need to use this iterator method for iterating over and performing the operation. Okay. Now this is, as we have already used this iterator. Okay. We have already created this iterator. That's why it is not, next time it will not create the iterator, because it always, iterator moves in the forward direction. Currently, it is pointing to the last element of our list, that is this B. That's why it is not going to be iterate again from the first element here using the iterator method. So that means you need to use the iterator only once. You cannot use this iterator multiple times. Okay. So iterator method only once you need to use, or once you need to create this reference. So you can remove this also, as we have created. Instead of this, I will use this, and T here also we will use. Again, we will get the same output or not, that we will check. Okay, so again we are getting the same output because this iterator has already finished its iteration, and we cannot go backward direction. We cannot go in the backward direction. Then what is the next use of this iterator, or how can we see the how to iterate over this list again? So that time you can use for loops, or there is one more, for each method. Okay, from this list, for each method, you can use the for each method also to retrieve the elements from the list. I am using character here. Okay, it will iterate over this list character by character by taking each token, and then it will throw. Index 98 out of bounds for length 6. Where is the 98? Sticky. It is taking actually the index 1 method, and that is why it is trying to remove the B index value. But I want to remove the value B, but it is not taking the remove object method. It is taking index method. Okay. Okay. So instead of that, I will use index 1 to remove the element. I want to remove the b variable, b value from our list. Let me check the values. B6, B6, X6. Where we have displayed it. Okay. We need to add some spaces so that you will understand the output. I can execute this. So this is the list before remove. After removing L element, so this is the current list we have. Now if we try to remove the value, I will again try to remove the value. Index 1 value we have tried to remove. Now we will try to remove the B value. As it is a character, that's why it is not taking the remove as object. Instead of that, I will use double quotes. Okay, now it is taking object. Let's see. Now here you can use, there is one more method into collections given. So that is for each method, which uses the consumer reference. We have already seen the consumer interface. Okay, so we can perform the display operation using consumer interface method also. It has a single method, single abstract method, right? So we are going to use C. I'm using the lambda expression just to display the each and every element value. Okay, using lambda expression, we are providing the implementation to the consumers method, and which is a void method which doesn't return anything. And here the for each method is added into this iterable interface since JDK 8. Now using this method also you can iterate over collection. Okay, B is not present. It is showing B is not present in our list. As I am using double quotes, it is not taking the B as a value. For character, it is giving some problem because internally index also gets converted from this B character. Suppose we will try to cast it into object. And then we will try to execute this. Now it worked. So you can see that the first B variable B value is gets removed. Okay, and the second one is as it is, kept as it is. So it is removing only the first occurrence. Okay, so these are basic methods which these add remove methods are there in the collection interface. The index-based methods like this add method, this remove method, index-based methods are from the list interface. So this is the first implementation class we have seen, that is ArrayList. Second, all these methods are same everywhere. Everything is same. Internally, it uses the different data structures. So if you only understood this method, add, remove, contains, get, etc., you can use any data structure according to your need. There is no need of creation or go through all the classes again and again, because it is nothing but the different data structures. Okay, internally it uses different data structures. You don't need to use it. So here linked list data structure is used. Linked list uses doubly linked list. Doubly linked list is nothing but it has a two address parts. That means two I will use this for integer. Two pointers, basically it uses two pointers. First previous, or the first pointer is used to store the address of the previous node, and next is used to store the address of the next node. So there are two address parts and one data part is there into the doubly linked list. It uses doubly linked list. So this is the data structure. It has first and last node. Okay, first has the previous element and next element. It is a node. It has first and last node, and it has previous address get stored. For each and every node, it has two values get stored. First one is the previous node. That means whatever the data we want to store, we can store it at particular index, and that index, which is whose next element is current element. So whatever the address is there, that gets stored here into the previous, and next holds the next element's address. So this is the linked list data structure. It uses node as a data structure concept. Okay, you must, if you know the data structures, then you know this. Linked list. It is the implementation of linked list data structure, which is a linear data structure. Linear means stored linearly. Okay, but where the elements are not stored in the contiguous locations. So in the array list, it is nothing but the dynamic arrays itself. Those are get stored into contiguous memory locations. That means if the data gets stored at 1001, the next element will be stored at 1004. That is known as contiguous memory locations. But in the linked list data structure, as they are holding the address part and data part, they are not going to be stored into the contiguous locations. They get stored anywhere in the separate location, and those are connected or linked together using the address parts. Okay, the elements are linked using pointers and addresses. Internally, it uses doubly linked list structure to store the data. This is the previous and next node. Okay, so all these methods you can use, same methods you can use on this linked list also. Add, remove, get. If you want to clear this, now here we will check whether it is empty or not. System.out.println list is empty. So we can use isEmpty method. ll.isEmpty. It will display the isEmpty, whether it is empty or not. If it is empty, it will return true. Now we can add the element here, as I'm using integer data type. I'm storing two values into it. Now again, we will check whether the list is empty or not. It will return true. Sorry, false, because list is not empty. Similarly, if you want to see the size of the list, we use size method. Okay, size method will return the number of elements present in our linked list. I will execute. Now you can see the linked list is empty first, then it will be non-empty. We have added two elements, and the current size of the array is, or list is 2. So list there is iterator which is provided by the iterable interface. So list interface has its own iterator also named list iterator. You can use list iterator also to iterate over any list, all the list references, okay, or all the implementation classes. You can use only for the list interface implementation classes. This, as the name suggests, it is a list iterator. So list iterator has two more additional methods than the iterator. Okay, so two more methods, that is a has previous and previous. Similar to these has next and next, this list iterator can be used for iterating previous elements. So I will use while list iterator dot, you can see has next, has previous element. We can iterate over it. System.out.println list iterator dot previous is the method. Now this list iterator, if we want to iterate in the backward direction, we must use here the last element as the index so that it will iterate in the backward direction. Using has next and next, we can iterate in the forward direction. Okay, so here I am passing as a list dot, sorry, ll dot size as the index to start with the iteration. Now we will execute this. So you can see 63 and 85 are the values. These we are getting as a in the backward direction. Okay, so this is how the list iterator also works in the on only the list interface. Okay, clear till here? Anyone has any doubt? Clear? Okay, so these are methods are same. We can use any methods similar to on all the different collections. All has the same methods. Okay, according to the data structure, it will little bit changes, but not more. So if you understand that mostly in the collections part, in interview only gets asked related to the difference between these different data structures or different collections. So you must know the difference according to the data structure. You can always say that. So next part, we will continue tomorrow and we will try to complete it tomorrow itself. Okay. Thank you, everyone. Bye. We will stop our session for today.